the video for this last section over here, 1.7. And as you can see, this is going to be all about linear and absolute value inequalities. So we'll go ahead and get started, and the others can join us in. So we've talked about equations in the first part of this chapter, and now we want to deal with inequalities. Now, when we are talking about inequalities, basically instead of having the equal to symbol, we of course have the less than, equal to, greater than, and greater than or equal to symbols. And then, when you're trying to solve these inequalities, a big part of it will be very similar to what we did with equation solving. But, of course, there's going to be a few things which will be a little bit different from equations when you're working with inequalities. But before we get into, equation solving, I want to make sure you guys are comfortable with the interval notation. So just to make sure, when you are looking at inequalities in the form, let's say x is greater than 3. So when we are trying to write this out in interval notation, we are basically saying all numbers that are greater than 3 will satisfy our variable x over here. So when we write this in interval notation, we actually go ahead and write it as 3, going from 3 to infinity, and you will see we have a parentheses on 3 and a parenthesis on infinity. So since this is a strictly greater than symbol, it's just x greater than 3, we have to use the parentheses on 3 because that tells us we are not including 3 in our answer set. It's just going to be any number which is greater than 3, and of course all the way to as large as the numbers can get. So you're going towards positive infinity. So a number greater than 3 can be even in decimal terms like 3.00001. That is a number greater than 3, which means that will also satisfy our value for x. So that's why we always write our interval notation in this form, where you are writing the 3 down, but by putting the parentheses before the 3, we basically know we're talking about not including 3 in our answer set. Now, if you wanted to include the number, then, of course, your inequality has to show that. So it would end up looking something like this, where you have x is less than or equal to 4. So when you have that little equal to along with the inequality, then that tells us that, yes, 4 can also be part of our solution set, but any number smaller than 4 can also be included. So when we write this as interval notation, then you will see instead of a parentheses, we actually put a bracket next to 4. So the bracket is telling us we are also including 4 as part of our solution set. And then like you saw with the 3 to infinity, when we're putting parentheses next to 3, the parentheses is telling us not to include the number 3. So if you want to include a number in your solution set, we put a bracket on it. If we don't want to include it, we put parentheses on it. And then of course, when you're graphing it also, you can kind of see with these two graphs over here, we either put an open circle or a parentheses on 3. So that's telling us, again, we're not including the number in our solution set. And then on this bottom graph over here, if you wanted to include the number, you either put a closed circle, or we like to use brackets when we are including numbers. So just a little bit of a difference between, when you are including or not including your endpoints. Now, in both of these examples, you will see with positive infinity and negative infinity, we are using parentheses again on infinity. Because, the idea is infinity is technically not a number, it's just a symbol, which is telling us, positive infinity means our numbers are getting really, really large on the positive side. And negative infinity, of course, means our numbers are getting really, really small, of course, going on the negative side. So they just tell us that our numbers are headed towards infinity, but they're not actual numbers themselves. So infinity and negative infinity, we always use parentheses on them. Doesn't matter, if we want to include those numbers. Since they're technically not numbers, we never use brackets on infinity and negative infinity. So that is something you always want to keep in mind when you're working with interval notation. And then we have these little, charts throughout the handout, which just kind of show you the different types of interval notations we can have. So we can have unbounded intervals, and that basically means we will have infinity or negative infinity as part of those interval notations. So you can see with the different types of examples, when x is greater than a, what does our interval notation end up looking like? X is less than a, or if you are using greater than equal to or less than equal to, then you know how we change our interval notations, and then of course each of the graphs to represent those interval notations. The last one here is when we are basically saying all real numbers will satisfy our inequality. That means every number on the real number line is being included. So everything from negative to positive infinity, and of course graphically, that means you're shading the entire number line. So just make sure you are comfortable with the interval notation, because that's going to be a big part of when we write our solution sets down for inequality. Because with equations, you may have just one single number as an answer, or maybe a couple different numbers. But when it comes to inequalities, you are always going to have these interval notations, because your numbers are always going to be either between two numbers, or they are going to be like you have here, from one number to positive infinity, or from negative infinity to a number. So it's always going to be one form or the other. Now, when we get into solving these linear inequalities, as I mentioned before, a lot of the process will stay the same as we work with equations. But let's take a look at some of these properties over here. So let's say by default, we have our inequality as A less than B. So with that inequality, you can go ahead and add or subtract the same number from both sides, and that's happening in number 1 over here. And in this case, if you're adding or subtracting a number on both sides of your inequality, nothing changes. Everything will stay the same, just like it would in the equation. Now, if we were looking at multiplying both sides of our inequality, now there's going to be a difference over here. If you multiply with a positive number, then your inequality stays the same. This inequality symbol and everything will stay the same. However, if you are multiplying both sides of your inequality by a negative number, you should notice that the direction of your inequality symbol changes. So originally we had A less than B, but you will see when we ended up multiplying by that negative C, the direction of our inequality changes. And that same thing you will notice happens also if you're dividing by a negative number. So again, if we divide by a positive number, nothing changes in our inequality symbol. But the moment we divide both sides by a negative number, okay, Trey, I just saw your message, but I was glad to see Philip was able to join us. So coming back to our division by a negative number, again, the direction of your inequality symbol changes. So only when we are multiplying and dividing by negative numbers, the direction of your inequality has to change. Otherwise, adding and subtracting numbers on both sides or multiplying and dividing by positive numbers does not affect our inequality symbol. So two things you definitely want to keep in mind. So let's take a look at a couple examples here from our homework. And again, like I said, hopefully you have seen the video lecture, so you are familiar with all of this. So this is just a quick review. So I want to make sure you are comfortable, writing your answers in an interval set from inequalities, or in this example, they're giving us the interval set and they're asking us to write it as an inequality over here. So just to kind of show you for this guy here, let's go ahead and do a number line. This is positive infinity to the right, negative infinity to the left, 0 somewhere in the middle. So this one here is telling us our interval notation is going from negative infinity to 5. So 5 would be over here. You should notice that we do have a bracket on that 5. So we are putting a bracket over here. And then since this is saying going from negative infinity to 5, of course, we are looking at this as being our solution set. So this would be our shaded portion on the number line. and then we have a bracket on our 5. So how will you write this as an inequality? What kind of symbol would you use? And, you know, out of options A, B, C, and D, which one do you choose? So which one would you go with?
Go with C.
You're going with C, okay. And then what would you type in the answer box? Okay, so on the chat, we've got James, Abdul Aziz, and Alicia. You guys are also going with C. And
You would
what are
put
you type?
5 in the box, right?
Yeah, exactly. You want to use the number 5. So the idea is we are saying that our X variable, since you are looking at the left-hand side, you know, part of the number line being shaded, that's definitely going to be the less than. And since we have the bracket on our number 5, that tells us we are also using the equal to symbol. So that is going to be X is less than or equal to number 5. So yeah, very nice. You will be picking option C as your answer and then just typing in 5. And there we go. Okay. And then something similar on the next one, where they're actually now giving you the inequality and asking you to put it in interval notation. So in interval notation, how would we go about writing this guy? So this one, they are giving us X is greater than or equal to -3. So this is going to be our -3. They're talking about greater than. So of course, we are going to the right-hand side, because that's where the numbers will be greater than -3. And then again, since we have greater than equal to, that equal to means you are also including -3 in your answer set. So now what would your interval notation end up looking like for this one? Okay, let me see. So we've got Nathan and James, you guys are going bracket, -3 to infinity, and then parentheses on that. Very nice, yeah. So we're starting at -3. We've got a bracket on -3, and of course we're going to the right-hand side. So that's going to be our infinity on the right. Okay. What is that, Oliver? Okay, and Abdul Aziz, you've got parentheses infinity and then -3 in brackets. So why did you change that order? Oh, okay. Because, you know, guys, always keep in mind, we have to put the smaller number on the left-hand side when you're writing your interval notation and larger number on the right-hand side. So between -3 and infinity, -3 is the smaller number. Now, if you had negative infinity and -3, then yes, negative infinity is smaller than -3. So always make sure you're putting the smaller number in the left-hand side and the you know, larger number on the right hand side, okay? Let's see, Oliver, -3, including that with bracket and infinity. Okay, very nice. So let's go ahead and type this in. We will need to make this guy smaller. And then over here, we will have bracket, -3, comma, and then infinity. Of course, you can see it's at the bottom of our screen here with the menu option. So just click on that and then parentheses. And then we'll do a quick check over here. Alrighty, very nice. So just a couple examples to work with the interval notation. Now let's look at solving a linear inequality over here. So let's take a look at this guy. And where do you think you would begin for a problem like this? What would be your starting point?
Yeah, x by itself.
Yeah, let's try and get x by itself. So let's go ahead and combine like terms. So we can start by, I guess we could move 5 to the other side. So how about we start by adding that 5. So that leaves us behind with 1/2 x less than 1/3 x plus 9. So since we moved the 5 to the right, now we can go ahead and move our 1/3 x to the left-hand side. So for that, we'll need to subtract. This cancels out here. We are left with 9 on the right-hand side. And then let's see what happens when we subtract our left-hand side. So that would be 1/2 x minus 1/3 x. And what do we do for that? We've got different denominators, right? So what would we do for that first?
You'd find the least common denominator. Wait, is it least common denominator or greatest common denominator?
Least common denominator, yeah.
Okay, that's what I thought.
That's okay. Yeah, and James, it's going to be number 6 because, yeah, it's got to be a number large enough that both 2 and 3 can divide evenly into that number. So, yeah, very good. Our least common denominator is going to be 6. So, of course, that tells us multiply the first fraction by a 3 and multiply the second fraction by a 2. And we will end up getting basically 3/6x minus 2/6x. And, of course, that comes out to be what? Yeah, there you go. So keeping the same denominator, because that's the idea. Once you find that common denominator, you're just subtracting the numbers on the numerator. So 3 minus 2, of course, gives us 1. And we end up getting 1/6 x. Okay, very nice. Abdul Aziz and Nathan. So coming back to our inequality over here, you will now have 1/6 x less than 9. So what do you do to get that x by itself? Yeah, multiply by 6, right? Because you want to get x by itself. So if we end up multiplying both sides by 6, on the left-hand side, that's 6 and the denominator 6 cancel out. 1 times x is just x. And, of course, we end up getting what, 54 on the right-hand side? So now they are going to ask us to write this as a interval notation. So how are you going to write this in interval notation? We can take a look at our graph here again. We're talking about 54, and that's less than 54. So if it's less than 54, do I use parentheses or bracket?
You'd use parentheses, right? Because it's less than or.
Yeah, because there's no equal to
not
sign,
equal.
right? Okay, so yeah, since it's only less than, you are only looking at using parentheses, and then of course you're shading the left-hand side. So what does that interval notation look like? I've got, let's see, James, Abdul Aziz, and Nathan, you guys have negative infinity. Okay, Abdul Aziz, looks like you're missing a negative on that. 254. Yeah, so just the way it shows up on the number line is exactly how you write your interval notation. Okay, let's see, Alicia, negative infinity 254, okay. So yeah, we are going all the way to negative infinity on the left-hand side. Remember, we always put parentheses on negative infinity and positive infinity. And then 54, since we do not have less than or equal to, we only have a less than, that means you're not including 54. So parentheses on that also. Alrighty, so let's go ahead and put this in.
So I have a question on the solving of this whole thing. I multiplied both sides by 6 before I moved them 1/3 x. Is that wrong in order of operations or anything like that? Because I got the same answer.
Did you start the entire inequality by first multiplying by 6?
Yes.
Okay, so you multiplied basically your 1/2, the -5, the 1/3, and the 4 by 6.
Well, I moved the 5 first.
Oh, you did move the 5. Yeah, because that should be fine, because you would have then ended up with, what is that, 3x less than 2x plus 18? No, you're multiplying by 6. 54, yeah. Yeah, and so that works out exactly the same, because, you know, if you look at the way we did it, we still ended up multiplying everything by 6. We just did it at a later stage than what you did. So yeah, what you are doing works exactly the same way.
Okay.
Yeah, wonderful. Very nice. All right, guys, so let's go ahead and type our answer in here. So again, we are doing parentheses, negative infinity, and then comma 54, close parentheses, and we are good to go. Okay, now let's talk about our graph over here. So out of these options, and I'll try and make this just a little bit bigger, which one would you choose as your graph out of A, B, C, and D?
B, right?
You're talking about B. Yeah, let's see, something just popped up on chat. Okay, Alicia and James, you guys are also going with B. Yeah, because again, you can see this is where we are not including our 54. This guy has a bracket on it, which means it's being included, and that's not right. These guys are, of course, shading on the right-hand side, so they are incorrect. So yeah, exactly, it has to be option B. All right, let's do again a quick check on that. And there we go. Alrighty, very nice. So that's just a couple different types of examples you have on solving these linear inequalities. Now this example over here, I would recommend, if you want to make it, you know, simpler and easier to work with, go ahead and multiply both sides of your inequality by that denominator of -5. And then once you've gotten rid of the denominator, then you can go ahead and solve this inequality. So, you know, when you're working through homework, give it a try and see how that goes. Okay, so these couple examples are actually getting into how the union and intersection of your interval work. So let's talk about that over here. So anytime we are working with compound inequalities, that means that we are basically taking two simple inequalities and joining them by the word and or by the word or. And then depending on, you know, which word is being used, is it and or, we will have to look at intersection or union of our, sets or our interval notation, if you will. So when we are talking about the intersection of sets, that is when we use this symbol, which kind of looks like an upside down U. That's the symbol for intersection. And then when we are talking about union of sets, you know, that's of course more like the U symbol over here. So the difference between the two is when we're talking about intersection means we're looking at two sets, A and B, and anything that is common between both the sets is what we include in the intersection. So if you just think of these as being sets of numbers, if you have, you know, some numbers in set A and those same numbers are also in set B, so your intersection will have only those repetitions, the common numbers between the two sets. And, you know, perhaps you guys have seen this drawn as Venn diagram, so where they do, you know, the two sets A and B. And the idea is whatever is in this little overlapping area is going to be common between both sets A and B. So these numbers are in set A and they are in set B. So that's usually what we refer to as our intersection. So whatever number is not common, you know, that gets, you know, sent out to these outside areas. But in the middle where you're seeing the overlap, that's going to be where we have those common numbers between set A and set B. So that's your union, sorry, intersection of sets. Now, when we're talking about union, union basically means you take everything that's common and then you also take everything that is not common and put them all together. So with the union, we would definitely take what's in here in the common area, but then we would also take everything which was on the outside in set A, everything on the outside which was in set B, which was not common, but we go ahead and take everything together, and together, you know, all of this ends up making our union. For that matter, with the union of sets, you can actually have two sets that have absolutely nothing in common. So they would be completely separate sets, nothing in common. And you would still take all the numbers from set A, you would take all the numbers from set B, and you would go ahead and put it together to create your union between sets. So union just basically means take everybody from both your individual sets and put them together. If you have anything in common, you include those numbers also. If you don't have anything in common, you include those. But the intersection, that's only for the common numbers. So as long as they are both available in both sets, you are good to go. So, and inequalities are always going to be based on the intersection, and the or inequalities are always going to be based on the union. Now, these three-part inequalities are actually also based on your and inequality, basically, which means you are also looking at an intersection when you're looking at these type of inequalities over here. So let's pick a example from our homework over here and let's take a look. Yeah, let's do this guy over here. So this, as you can see, is an and inequality. So we'll go ahead and solve each one of our simple inequalities. So you are given 3 greater than 8 minus x and 2 plus 0.5x is less than 7. So if you solve each one of these individually, what kind of answers are we looking at for our x value here? So don't send your answers just yet, just have your answers ready. When I ask you to, you can send it in, so not just yet, just wait. Okay, if you are ready or you need a couple more seconds over here. All right, go ahead and send your answers in, guys. Okay, so I've got 2.5 to 5, I've got 5 to 10. Okay, x is less than 5, x is less than 10. Okay, Alicia. So nobody seems to have a consensus on the answer here. Oliver, you've got 5 and 10. So I'm actually looking for the inequality like Alicia has, or James just sent us in. So you've got, James is x is greater than 5 and x is greater than 5, looks like on both of them. Sierra, you got x is less than 10. So you should be having two answers coming from, of course, each of those simple inequalities. So let's take a look here. We are trying to get x by itself. So we can start by subtracting that 8, move it to the left-hand side. Okay, Abdulaziz, you've got x is greater than 5 and x is less than 10, okay? So if we are moving the 8, 3 minus 8, of course, gives us negative 5, and that's greater than negative x. We always want to keep our variables positive, so you can multiply or divide both sides by negative 1. Now, we are dividing by a negative number, so the direction of our inequality has to change. So that greater than will become less than, and then this will become positive x. This will become positive 5. Okay, so looks like it is x greater than 5, and most of you did have that. Okay, Oliver, looks like you came up with that also. And if it helps, you can rewrite this. So we've got x greater than 5 as long as that open mouth is facing the x value. And then let's look at the other side. We need to get x by itself. So let's start by subtracting that 2. Then we have 0.5x is less than 7 minus 2 is 5. And then you end up dividing both sides. And we are dividing by a positive 0.5. So that does not affect the direction. And since you're dividing 5 by 0.5, that will actually make it 10. So x is less than 10, which I think almost all of you got that. Yeah, looks like it. Okay, so let's try and put this together now and see what do we have here. So infinity here, negative infinity here, 0 somewhere in the middle. We've got 5 and 10. So let's take a look at the first one. We're saying x is greater than 5, but not including 5. So that's greater than 5 going to the right-hand side. For our x is less than 10, again, we're not including 10. So parentheses on the 10, but this time we're going less than. So you're going, of course, to the left-hand side. So you will notice here, since this is and inequality, with the and inequality, we are talking about intersection. So that means only where the overlap happens is what you include in your answer set. So as you will see, the overlap is happening between the 5 and the 10. So this is the area that is going to satisfy our compound inequality here. So we are looking at numbers between 5 and 10. So when you write your interval notation, and I'll have to go back and look at, one of you sent me that as your answer. So let me see. Abdul Aziz, yeah, you had that interval notation. So this is going to be between 5 and 10. And of course, we are not including either of those endpoints. So remember, you are only looking at the intersection. That's why we're not including anything which is on the right-hand side of the number 10, or including anything to the left-hand side of number 5. So when you're choosing your graph, it's basically going to be between numbers 5 and 10 with parentheses on both ends and just shaded in the middle. Okay, so let's go ahead and type this answer in. So we're looking at 5, 10, parentheses on both ends. Alrighty, very nice. And then let me go ahead and clear this out. So what graph do you end up choosing again between A, B, C, and D? Okay, James, you're going with graph C, which is going to be between 5 and 10, and you've got parentheses on both ends for number C. Alicia, you're also going with C. Oliver, Lowell, very nice. If you look at any of the 2 other graphs that we have, or the 3 remaining graphs, we do have parentheses here, but we have a bracket on the other end, so that guy doesn't work. If we look at the other 2 graphs over here, oops, with these other 2 graphs also, you've got bracket on one side, parentheses on the other side, and of course brackets on both of these. So, obviously none of them are going to work out. All right, very nice. So that means we are going with graph C, and we'll do a quick check over here. And there you go. So just keep in mind with the and inequalities is where you are looking for that overlapping portion for your answer choice. This is an or inequality, and I'm actually going to show you the or inequality when we are looking at these absolute value functions over here. So let's get into our handout. So, when we're talking about absolute value inequalities, you're still using the same definition for an absolute value, which means you're looking for the distance from 0 for an absolute value number. So when we are looking at these inequalities and we say absolute value of x is less than 5, basically that means we're looking for a number whose distance will be less than 5 from 0. And we know we can go in the positive direction or the negative direction from 0. So, that's why we can have a number which would be between -5 and +5, as long as you're not including the endpoints, because, they don't want a distance of exactly 5. They want a distance of which is less than 5. So you will see this ends up becoming our interval notation in this case. Now, if we change the direction of our inequality and we say, okay, we want the distance of x to be greater than 4. So absolute value of x greater than 4, that means for a distance greater than 4, you have to go on the right-hand side of 4, or we have to go on the left-hand side of -4, because all of these distances will be greater than 4. So you will see when we write this solution set, it comes out to be between -infinity and -4, or between 4 and infinity. So you should be able to notice just the different ways we write these interval notations. Of course, we talked about the unbounded interval over here, but then you can also have these bounded intervals, and bounded basically means you no longer are using infinity, you're just staying between two numbers, and then you're either keeping it as an open interval where both ends of our endpoints are not included, just like the example we saw before. If both ends are included, we're putting brackets on both ends, we say it's a closed interval. And then, of course, if one side has a bracket and the other side has a parentheses, then we say it's either half open or half closed, like these two at the bottom. You can also have this example we just looked at, where we are actually using the union symbol to combine two different sets of interval notations. So as you will see in these graphs over here, they are at the opposite end of our number line. There's obviously no overlap happening. They're not touching each other. So since they are two completely different sections, we have to use the union symbol. It's kind of like an addition symbol, but for the set set theory concept over here. So that's why we are basically saying, let's bring the interval from the left-hand side and put it together with the interval from the right-hand side by using that union symbol. And that only happens with absolute value inequalities that have the greater than or the greater than equal to symbol. And that's how we end up writing them down. If you have a less than symbol, so absolute value less than k or absolute value less than equal to k, you can set it up as a three-part inequality, or you can also set these guys up as an and inequality. So you can set up the less than equal to as and, the greater and greater than equal to as or inequalities. So basically your absolute value inequalities turn into compound inequalities. So let's take a look at these examples over here. So we'll do one with the less than symbol. So we are given 3x minus 1 inside the absolute value symbol is less than equal to 5. So you can either set this guy up with the and inequality. So you would set up the first one as 3x minus 1 less than equal to 5, just like it's given to us in the problem itself. For the second part of this inequality, we will have 3x minus 1. but now change the direction of your inequality symbol and put a negative on the number 5. So you can set it up like this with the and inequality, or you can also do it as a 3-part inequality, which is where you actually write this as 3x minus 1 less than equal to 5, but then on the other side of 3x minus 1, we would have, again, still less than equal to, and then negative 5 on this side. So you can set it up as a 3-part inequality, or like I said, you can set this up as an and inequality. Okay, so if we go ahead and solve each of these 2 inequalities, what will we get up as our answer as? And we're going to do it both ways so that I can show you it works as an and inequality and also as a 3-part inequality, and then you can choose whichever setup you prefer better. So let me see what answer you come up with for these guys. Okay, Abdulaziz, you've got between negative 4/3 and 2, including the endpoints. Okay, James, you've got less than equal to 2, okay. Now, hopefully we should be seeing 2 different numbers with this. So let's see, Nathan, you've also got negative 4/3 and 2. Same as Abdulaziz for Alicia, okay. So basically, of course, we are starting out by adding 1 to both sides of our inequality, which will end up giving us 3x is less than equal to 6 divided by 3, which will give you less than equal to 2. And I know that's what James, you had. And then on this other side, we are taking 3x greater than equal to, now since it's negative 5 plus 1, of course, that becomes negative 4. So that's where that negative 4/3 is coming from that some of you had. Now, since this is an and inequality, that means we are looking at the intersection. So we are going from, let's see, positive 2 and negative 4/3. So this guy is saying x is less than or equal to. So of course you're going to the left-hand side. And then the other side is saying x is greater than or equal to negative 4/3. So greater than, of course, then we go to the right. And as some of you had that answer, the overlap, of course, is happening in between those 2 numbers, including the endpoints. If you did it as a 3-part inequality, which will, of course, still get you to the same result. Okay. Yeah, Oliver, you've got negative 4/2, but I would imagine you probably meant to type negative 4/3. So with the 3-part inequality, you're still doing the exact same calculation, but you do it on all 3 sides. So when you do that, in the middle, that negative 1 and positive 1 cancel out, leaving us behind with just the 3x in the middle. And then on the right-hand side, we would have the 6. On the left-hand side, we would have the negative 4. And then when you divided it by 3, you will see we get the exact same result, but instead of being 2 separate inequalities, they're just going to be what I call as being sandwiched between these 2 numbers. So between negative 4/3 and 2. So when you do your graph, you're including both of the endpoints, so brackets on those, and then shade the middle part. And of course, your interval notation is going to be what many of you typed in the answer box. So in the chat, -4/3 and 2 inside of your brackets. You know, pick whichever one you like the best and go with that. Three-part inequality or writing it with the word and. So that's bracket -4/3, comma 2, and then close bracket again. Check your answer, and then let's do our graph. And again, which one is it? A, B, C, or D? Alicia, B, Lowell, Nathan. Yeah, because that's the only one where they have brackets on both ends. Of course, you can see over here, these guys over here have parentheses, so we know that's not right. Okay, very good. This one is selecting the entire number line, so that's not right. This one is a blank number line. So as you can see, all of those automatically tell us they cannot be part of the answer set, so it's got to be option B. Very nice. All righty. Good job, guys. So this was using the less than or equal to symbol with our absolute value inequality. Now, what if we used the greater than or greater than equal to symbol? So remember, when it's greater than, that means you are always going to end up with an or inequality. So you cannot do this as a three-part inequality. Just set it up as 1 minus x greater than 6. So same as it's given to you in the problem, just without the absolute value symbol. Then we say or. And then this one would be 1 minus x. Change the direction of your inequality so that becomes less than. And then, of course, we put a negative sign on the 6. So what will these two inequalities simplify into? So again, have your ready. Don't send it just yet. Okay, so Alicia, either put them with inequalities or interval notation. So that way I know what exactly you have. So, okay, guys, go ahead and send your answers in. Okay, so James, you're looking at x is less than -1 and x is greater than 7. Okay, x is less than -5. X is greater than 7. Nathan, you've got x is less than -5 and x is greater than 7. Okay, so James, how are you coming up with -1 then? Because I've got two answers here with -5 in it. Okay, what about the rest of you? Okay, Abdulaziz, you're going from negative.
Yeah, that should have just been -5.
Oh,
I pulled the wrong number down.
okay, not a problem. All right. Okay. And then let's see, Abdulaziz, you're saying 7 to infinity for the second part. Oliver, x is less than -5, x greater than -7. Shayna, x less than -5, x greater than 7. Okay, that definitely seems to be more of the answer over here. Sierra, x less than -5, x greater than 7. Okay, so let's take a look. Like I said, that definitely seems to be where most of your answers are going. So we start by subtracting the -1, which leaves us behind with -x greater than 5. And yeah, so when you end up dividing both sides by -1, that will definitely change the direction of our inequality symbol. So that becomes a positive x is less than -5, alrighty. And then on the other side, when we subtract that 1, we are again left behind with -x less than -7. So this is where you guys are getting that greater than. Again, change the direction of our inequality symbol, and x would be greater than +7. Now, I know some of you did send your answers in with the interval notation. So let's take a look at that. We've got x is less than -5 and greater than 7. So we're going in this direction here, and we're going in the left over here. And again, we're not including 5 or 7. So what does, I think, Abdulaziz, you had a little bit of a typo in your, yeah, exactly, in your infinity symbols. So you are actually going, if you again just look at the graph over here, the left-hand side, we're going from -infinity to -5. So that interval should be -infinity to -5. Again, parentheses on both, because we're not including -5. And then on the right-hand side, we're going from 7 to infinity, again with parentheses, because we're not including 7 either. And then like I was telling you before, since they are two completely separate shaded areas, to bring them together, we definitely need to use the union symbol. So when you're typing this answer in, you will actually see they do give you the union symbol in our little message box on the bottom. So you will see we have the union and the intersection symbol given to us. So let's start typing this in. So that's -infinity, comma, -5, close our parentheses. Then we do our union symbol, open parentheses, 7, comma, infinity. And of course, close that parentheses. Alrighty, and then now for our graph, again, which graph are you going with? A, B, C, or D? James, you're going with D. Nathan, D. Alicia, Shayna, okay. All right. Robert, Trey, Oliver, okay. So let's take a look at this. We are not including 5. We are not including 7. And of course, they're going in the opposite direction, just like we had when we did this. You should see these guys are using brackets. So, and of course, you know, this one is shading the wrong portion, but they are all incorrect. So just verify that none of the other graphs work, and you should be able to pick your correct answer. So just make sure you are comfortable working with, you know, the absolute value inequalities where you have the less than and the greater than symbol with them. Now, these last two examples are what I call as the special case of these absolute value inequalities, because you will see they have a negative number on the right-hand side. So you've got this absolute value of 7y minus 4 greater than equal to -3. So of course, we know absolute value is a distance. Distance has to be positive or it has to be 0. And then of course, we have our greater than equal to symbol over here. So let's just think about this problem for a minute. We are given 7y minus 4 inside the absolute value symbol. Now, you know, whatever value we use for y, we know this answer either has to come out to be 0 or it will come out to be a positive number, because that's how absolute values work. So just to show you, let's pick some values for y over here. We can start with something simple like y equals 0. So if we do absolute value of 7 times 0 minus 4, what kind of answer are we looking at this? Yeah, you are going to end up getting positive 4 because you know 7 times 0 is 0. 0 minus 4 gives us negative 4, but this is all inside the absolute value symbol. So absolute value of a negative number we know becomes positive. Now is positive 4 going to be greater than or equal to negative 3, which is what they gave us in the inequality? So is 4 greater than negative 3? Yes, it is. Yeah. So you know this is going to be true because 4 gives us a positive number. What happens if I use y equals, again, we'll keep it simple. Let's say we use y equals negative 1. What happens in this case? What kind of answer are you looking at with this one? So 7 times negative 1, and then you're subtracting 4 from it. James, yeah, because you will actually end up getting 7 times negative 1, which is negative 7. And then when we subtract 4 from it, that would give you absolute value of negative 11. But again, we know absolute value makes everything positive. Since it's a distance, this will become positive 11, which is again a number greater than negative 3. So you can see, and you know, you can try this with other y values if you want, but the idea is no matter what y value you choose, you are always going to end up getting a positive number on the right hand side. You can potentially get a 0 on the right hand side, but all of those numbers are going to be greater than negative 3 because negative 3 is going to be on the left, 0 is going to be on the middle, and you know all positive numbers are going to be towards the right hand side of 0. So no matter you know which of these numbers we end up getting, they will always be greater than negative 3. So James had actually sent that answer in the chat where the solution set was negative to positive infinity, because we're basically saying for the y value, you can use all real numbers because all those real numbers are still going to end up giving us an answer which will be greater than or equal to negative 3. So your interval notation will be negative to positive infinity, and your graph will basically be where the entire number line is going to be shaded. So this is definitely a special case because you don't actually have to solve these equations. Remember, having that negative number on the right hand side, we can't really solve these type of examples. So you just have to do a little bit of critical thinking here. So this guy here is going to be negative infinity to positive infinity. And then, like I said, it's going to be the graph C where you're picking the entire number line. Now, just another version of that same example. And this is with less than symbol. And then, of course, we have a negative number on the right-hand side, but doing a less than. The same kind of logic you want to think about like we just did with absolute value of 6 minus 7x. So if we pick a number for x as, you know, then keep it simple, 0, what are you going to end up getting here? So 6 minus 7 times 0. 7 times 0 is, of course, going to end up becoming 0. You just get absolute value of 6, which comes out to be 6. And think about this. Is 6 going to be a number less than negative 1? No, it's not. And you can do this with any other value for x. But we know, again, absolute value gives us either 0 or a positive number. So a 0 or a positive number is not going to be smaller than -1. They are not going to be less than -1. So in this case, it's basically the reverse of what we saw in the previous example, because no matter what value of x I use, I am not going to get a number which will be smaller than -1. So in this type of an example, that actually means there is no solution because nothing will satisfy this inequality. So we will have an empty set, which means our graph is going to be, obviously a blank line since it's an empty set. So that's kind of how these type of examples will work. And this is, of course, because you have a less than symbol in your inequality instead of a greater than, like you did in the previous example. So let's go ahead, and type our answers in this guy. So that would be empty set. And then click on continue. And of course, you're going with a blank line. So that's option D. Okay, so these last two examples are, like I said, the special case example where you're actually not solving the inequalities. And this only happens when you have a negative number on the right-hand side. So going back to your notes over here, as long as you have a positive number on the right-hand side, you can solve these inequalities. But the moment you get into these negative numbers, the greater than symbol will tell you it's going to be all real numbers. The negative to positive infinity, and this is where you are selecting the graph where the entire line is shaded. With the less than symbol with the negative number on the right hand side, this is where we have no solution. So it's an empty set. And of course, we know, as we just saw, our graph will be a blank line. Yes, Abdul Aziz, as long as you have a negative number on the right-hand side, that's going to be true. So if you have a greater than symbol, it will be all real numbers. If it's a less than symbol, it will be no solution. But make sure if you have positive numbers, then it's not going to work. You have to solve those. It's only when you have negative on the right-hand side. And then, again, you should have seen these examples with the applications for just, how these linear inequalities and absolute value inequality applications might end up looking like. So before we, move on, because this was the end for chapter 1, I wanted to see if you guys had any questions on what we did in section 1.7, or if you have in general any question from chapter 1.
So one thing that I just wanted to mention, when we were looking at problems 6 and 7, when you have a positive on the right side of the inequality, if it's greater than greater OR, so that helps remember that. And if it's less than, and I don't know, it's just something that I picked up.
That is interesting. I have never seen that in all the time I've been teaching this. That's interesting. Thank you. Right, it's an easy way to remember, which inequality you're looking at.
Yeah.
Yeah, very cool. Okay, any other questions regarding chapter 1 or section 1.7? Okay, so before we get into chapter 2, just to remind you, so obviously we will be meeting on Monday to take our chapter 1 exam. So you will be logging in just like you do for your class time. I will be giving you your password during class for the exam on chapter 1. Now just keep in mind, guys, you should have 90% grade on each homework section, and that also includes chapter P. So that would be, 90% on the chapter P homework sections and a minimum of 90% on the chapter 1 homework sections, because if you don't have that minimum 90%, then your quiz and exam do not open up So let's say right now, if you're still trying to finish homework and if you were to try and click on the quiz, it would give you that little message saying you haven't met the prerequisites, you should have a minimum of 90%. So just make sure you take care of that. Also, you have to have a minimum of 90% attendance to be able to take the exam. So I would definitely be looking at your attendance to make sure you are meeting that minimum requirement. So just make sure you're good on both those fronts. Even though we are not testing you on chapter P, that is literally a practice chapter, your prerequisite chapter, but you do have to finish the homework on that and have that minimum requirement of 90%. So just kind of keep that in mind. And then Monday, you will be coming to class. For this first exam, we're not going to be doing anything else in class that day, because I'm not sure how long each one of you will take to take your exam. Or some of you may be done early, some of you may need the entire class time. So we're just kind of playing around right now to see how you work and what kind of time you need. So basically, we will not be lecturing. You guys are only going to be coming into class to take your exam basically on Monday. And then on Wednesday of next week, we'll start lecturing where we left off today. So
Does the
questions?
quiz on Pearson, does that count as a grade or is it just practice?
So the quiz is for the grade. Yeah, quiz counts towards the grade. It's a practice exam. And in parentheses, you will see I have specifically mentioned it's not for a grade. So it's only the practice exam that does not count, but the quiz will. And you will actually not see your exam for chapter 1 till you come to class on Monday afternoon, because it's been set up to open right when class starts. So that's why the exam is not showing up right now. So don't get confused because you're not seeing the exam in your list of assignments. It will only show you the homework, the quiz, and the practice exam. But on Monday, when you come to class, you will see the exam will start showing up. Okay. Okay, so if you think of any other questions, definitely feel free to ask me. But I did want to introduce chapter 2 to you guys. And if you've not seen the video lecture for it just now, that's okay. You can always, take a look at it later on. Okay, no problem. Lowell, thank you for letting me know. So with this section and chapter 2, basically, we are now bringing in the idea of a function. So, functions are just like equations, but obviously they have a specific definition that we are going to be talking about. So we've looked at equations in chapter 1. We've talked about linear equations with just one variable. We've talked about equations with 2 variables. Remember when we talked about the line and the circle? And then, of course, we've looked at quadratic equations, which had our x squared, the second degree polynomial as part of it. So now let's talk about, what makes a function, different from just a regular equation. Okay, James, thank you. So just 2 different examples to kind of highlight this idea of why one is a function and the other one is not. So in this first example here, we're talking about, we've got $10 to spend on gas, and they're basically saying if you know what the price per gallon is, then that can help us determine how many gallons, we're going to get. So the number of gallons can be calculated once you know what the price per gallon is. And, basically, we take that $10 that we're spending on gas and you end up dividing it, by what the price per gallon is. And of course, that will give you the number of gallons. So right now, gas, I know it's different in different places, but I think the last I saw was like 209 or something like that. Maybe it's a little bit more or less in other places. So if you take that dollar amount and just divide $10 by it, you can easily see, we're going to get like 4 or 5 gallons somewhere in there as a round figure. So knowing the price per gallon is helping us determine the number of gallons that we purchased. Now, if we try and use that same concept with this number of hours we sleep before an exam, well, will that help us determine our grade? So will we be able to calculate by saying, okay, if you slept 10 hours before the exam, this is going to be your grade. Or if you only slept 4 hours before the exam, this is going to be your grade. But there's really no correlation if you really think about it. Maybe you will be more rested, you know, maybe your brain will be working a little bit better because you're not tired and exhausted. So there's definitely a possibility you may end up doing better on the exam because you may not feel as tired. But really it comes down to how comfortable you are with the material on the exam. Did you have enough time to study and prepare for the exam? So sleep really has no effect on it. So the gasoline example, we can definitely define as being a function because we were able to calculate the number of gallons based on the price per gallon when we know we're spending $10, but we cannot use that same relationship with the number of hours and the grade you make on an exam. So if you will look at the bottom of that paragraph, they're basically saying if the value of a variable y is determined by the value of another variable x, then basically we can say y is a function of x, which basically means that y can be determined by the value of x. A lot of times you will also actually see the terminology for this being as we can basically say that the value of y depends on the value of x. So y depends on x. Okay, so basically we're saying the value of y can be calculated once we know what the value of x is. However, there's one little thing you have to be careful about you know, when we're talking about functions. We are basically saying if there's more than one value of y that we can come up with for, you know, any given particular value of x, then in that case we're saying y is not a function determined, you know, it's not a function of x, or y is not determined by x. So in that case we would say it is not a function. So again, if for a given value of x you can come up with more than one value of y, then that cannot be a function. So we will not consider that to be a function. So let's take a look at some of these scenarios from our homework over here. Let me quickly pull up our 2.1 homework. Okay, so first couple of these are going to be definition examples. All right, how about this guy over here? So they're basically asking us to decide what relationship will be between our A and B variables. So can A be calculated if we know the value of B? So that's A is a function of B. Can B be a function of A, which means if you know the value of A, can you calculate B? Does it work in both directions or neither? So they're defining A as the radius of any coin and B as its circumference. So if you know the circumference, can you calculate the radius? If you know the radius, can you calculate the circumference for the coin? Okay, so let me see. Lowell, you're going with D, which is both. Abdulaziz, you said A, B is a function of A. James, you also said B is a function of A, and then Nathan, you went with D, where you're saying both, which means if you know one, you can find the other. If you know the second one, you can find the first one. Okay, Oliver, you're going with B. Alicia, you are also going with D. Okay, so Oliver, you went with A is a function of B. Okay, Shayna, you're also going with D, it looks like. Okay, so, you know, this is, honestly, they're talking about a coin, but, you know, we're talking about, in general, a circle shape over here. So when you're talking about the circumference of a circle, you know, that formula, and let me, okay, so for the circumference of a circle, your formula is 2 pi r. So you can see one of the variables is going to be the circumference, the other one is the radius. So if I know the radius, 2, of course, is a constant number. Pi, we know You can use an approximate value of 3.14 or just use the pi key on your calculator. So if you know R, you will be able to calculate C. If you know C, then to calculate the R, you just basically divide your circumference by 2 pi and you end up calculating your radius. So in this case, actually D is the correct answer because you will be able to do this in both directions. If you know the circumference, you can find the radius. If you know the radius, you can find the circumference. So yeah, very nice. And I know some of you went with just either option A or option B. So obviously you were thinking in one direction that this would work. If I know the circumference, the radius can be found, or if I know the radius, the circumference can be found. But as you can see, it obviously goes, both directions in this case. Right, very nice. Let's take a look at another scenario over here. So this one is talking about S is a person's age and T is the number of days since their birth. So the age for S and T represents the number of days since they were born. So if you know the person's age, can you calculate the number of days since their birth? And of course, the other way, if you know the number of days since they were born, will you be able to calculate their age? So is it one way or the other way? Is it both or is it neither? So don't send your answers just yet. I want to give everybody enough time to think about this example. So when I ask you, you can send it, but don't send it just yet. Now remember, when they're saying S is a function of T or T is a function of S, the first, like for part B, when they say T is a function of S, that means if you know S, you should be able to calculate T. If you look at option D, where they're saying S is a function of T, that means you should be able to calculate S if you know what T is. So just make sure you're understanding that terminology, okay? All right, go ahead, send your answers in. Okay, so I've got B, A, D, B, D, A. Okay, so you're going with both. T is a function of S and S is a function of T. Okay, so obviously none of you are thinking C should be an option. It's got to work one way or the other. And then some of you are thinking D, the A as both the options. All right, so let's think about this. If I tell you my friend is 35 years old, that's all I tell you. They are 35 years old. Will you be able to calculate the number of days since they were born? No, because we don't know what month they were born in, right? And even if we knew the month, if we don't know the exact date, again, we don't know exactly how many days it has been. So obviously that means option B is gone, because if you know the person's age, you cannot calculate their exact number of days. So
I almost asked about that.
Okay. Yeah, and I know a couple of you did pick that as your option in here. So B does not work. So if B does not work, that automatically actually takes A out of the picture also, since one of those directions is not working. So now we are thinking of S as a function of T, and I know a bunch of you picked that as your option. So this one here, we're saying if we know the number of days, which is T, then we would be able to calculate their age, which is true, right? So if they've been born for 5,677 days, of course we can work backwards and calculate, which I think that person would be really, really old if they've been around for 5,000 some odd days. But, we can still calculate. So that's going to be option D over here. And yeah, very nice. So you can see that one definitely works out in our favor. Okay, so let's clear that one out and let me see if we have another example. We do over here. Okay, so let's take a look at this guy. Here they're giving us A as the base of the triangle and B as its area. So kind of like the circle point, circumference, and radius, but now we're talking in terms of a triangle. So think about this one. Don't send your answers just yet. A as the base of the triangle and B as its area. So if we know the base, can we calculate the area? If we know the area, can we calculate the base? Okay, go ahead and send your answers in. Okay, so we're going with B, 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 B. Neither. Really? Why? Okay, so let me see, what are you kind of thinking for this example?
Because you need the height as well, right?
Yeah, that's what I was thinking. I think we were missing a variable, but I'm really bad at triangles so far, so I don't know.
No, you are perfectly right. And Abdulaziz just sent the formula for the area. So it's got to be 1/2 base times height. So what happens with the triangle? Go ahead. So you know what happens with the triangle, and it doesn't matter what kind of triangle you have. You can have something like this, where this would be the base, and you know the height is always that perpendicular distance. So you definitely need base and height when you are calculating. And you know here they're only talking about area and the base. There's no mention of the height, so we don't know, you know, what's happening with the height. So yeah, very nice. Let's take a look at that option and see what we get. So make this guy smaller. There we go. And yeah, as you can see, you guys were correct, because till we don't know what the height is doing, we are not going to be able to calculate the area or find out the base if we just know one or the other and don't know anything about the height. So I'm kind of glad they gave us this example, because sometimes, you know, these examples are auto-generated, so I'm never sure what they'll show up. So if you look at our handout for this section, you will see we kind of have a similar example over here, where we're talking about A being the length of the rectangle and B being its perimeter. But you will see in this example, we are definitely mentioning what's happening with the width. We are saying that width is going to stay at 5 inches. So for this example, where A is the length, B is the perimeter, we know the width stays at 5 inches. What would you say about the relationship between A and B in this case? Yeah, it's going to work in both directions, because we know we have that static number for the width. So if you know the length and the width together can help us calculate the perimeter. If you know the perimeter, then you can basically take the width and the perimeter and, you know, break that down and find the length. So yeah, very nice. In this case, both A and B are going to be functions of each other. So there we go. Oops, that should be an A. Alrighty, and then with the second example here, we are defining A as being the final exam score for a student and B being their semester grade. So A is the final exam score, B is the semester grade. So what can we say about the relationship between A and B? If we know the semester grade, can we calculate the final exam score? And of course, if we know the final exam score, can we calculate the semester grade? So kind of let me hear what you guys are thinking in terms of this example. Okay, so James, you said neither unless the final is the 100% of the grade, and Abdulaziz, you're also going with neither. Alicia, you're also going with neither. Okay, so what is your thought process with the neither, other than, you know, if the final exam doesn't give you the 100% of your grade, what else are you thinking?
You don't have all the information about the rest of the semester grade, so you can't really calculate the final exams out of that.
Yeah, because we don't know if homework quizzes, kind of like in our class, right? If homework and quizzes and chapter exams have a weighing or not. But the other thing that also fails in this case is, remember how we had talked about for the same given value of X, we cannot have two different values for Y. So if you think about this, you know, there can be multiple students in the same class who could get a grade of A or a B or a C or, you know, whatever grade it is. But that does not necessarily mean if, you know, 3 students got an A, that means they had the same final exam score, right? Because obviously they could have different scores. And in the same sense, if 4 students had the same final exam score, does that necessarily mean they will have the same semester grade? So yeah, we don't have enough information, but also that idea of the repetition is definitely very possible in an example like this. So in this case, they are definitely not going to be functions of each other. So when we are defining a function, we're basically saying, you know, think of that as a set of ordered pairs in which we are saying no two ordered pairs can have the same first coordinate and different second coordinates. So if you just think of your set of ordered pairs as being our ordered pairs with the X and Y values in it, so we're basically saying for the same X value, we should not have two different Y values. So all the different equations and everything we have looked at, in general, we can say, you know, that's a relation between two variables. So, you know, if you have an equation with two variables, we can say that's a relation between X and Y. If we can show that they have this special relationship where the value of Y depends on the value of X, and for the given value of X, we only come up with one single value of Y, there's going to be none of that repetition happening, then we would say, yes, this is a function, and basically a function is a special type of a relation. So keep in mind, they can all be relations, but only some of them will be a function. So it's going to be a very special, if it meets this definition, we can call it a function. So I just kind of wanted to introduce this idea of what a function is. We will definitely pick up with identifying our functions and what that ends up looking like for next time. So remember, on Monday, we are going to be taking our chapter 1 exam. I have office hours tomorrow from 12 to 1. And if for any reason you're unable to meet me during that time, but you have a question, you know, definitely feel free to send me an email. If you need any extra help, just kind of, you know, get in touch with me and let me know. Keep in mind, we do have some tutoring hours available through our Learning Commons also. So if you're not able to get a hold of me, you can try and get a hold of our Learning Commons tutors also. But just make sure you are preparing yourselves. Now, you guys can actually also use the office hours on Monday right before class. So remember, on Monday from 1 to 2, I will also have office hours. So if there's just any kind of confusion you have last minute, you'd like to clarify, we can definitely talk on Monday afternoon also. So just make sure you're practicing well. You know, I just wanted to give you an idea in terms of your quiz, practice exam, and the chapter exam. All of them are using the same questions. So, you know, if you get a chance to look at your quiz, and I don't know how many times you will end up taking it, 1 or 2 times. Remember, you do have 3 attempts on the quiz. So you can definitely get some practice when you do the quiz. I would ask you to look through the practice exam. Now, practice exam probably has like 60, 70 questions in there, because as you will see in our homework, you know, for one concept, there might be 3 or 4 different types of problems. So like you saw with those absolute value inequalities, we had 2 or 3 different types of options. So the practice exam actually just brings every single type of question in there. But then when you actually take your exam, out of, you know, if there's 3 different questions for the same problem, only one of them will show up. And in the practice, all 3 of them show up. So what I would say is, don't do all the questions in the practice exam. Just click through all of them. As you are going through each question, just kind of mentally go over, okay, so how would I solve this problem? What method would I use? And if you are confident that I know this is exactly what I need to do, move on. If you look at the question and you're like, okay, I'm a little uncertain, I don't know what exactly I need to do here, then that's the one you probably want to solve and make sure you go through the steps. So don't get afraid because you see like 60, 70 questions in the practice exam. That's why it's not for a grade. It's just to help you study for the exam, but you will see every different type of question which will show up on the exam. Now remember, your exam only has 15 questions, 15 questions on it. So it's not a very long exam, you know, but obviously make sure you're comfortable with each different type of question that you see on there. Okay. Anything else you want to ask me before I let you guys go? Okay. All right, everybody. So we'll call it a day and have a wonderful weekend. It's really so weird seeing you only for one day this week, but you know, hopefully if you have any questions, I will see an email or something from you. So just stay in touch with me if you get stuck. All right, everyone, have a wonderful weekend. Be careful, be safe, and I'll see you Monday afternoon. Bye, guys.
Hi, Miss.